Assalamu alaikum. Today we'll be going over the topic of arrays. So let's just go over what an array is. So it is a data structure. So it is a data structure that contains several elements of the same type. So it's basically a structure in which you store several elements, like you use variables to store several elements. So if you have multiple variables who are have the same type, so you can store them in an array, right? So we'll go over how an array basically looks. So this is how an array basically looks. This is a 1D array. So there's a difference between 1D and 2D arrays, and we'll go into much further depth related to that. And in order to declare such an array, so we're going to use the function just as we declare variables, we're going to declare this array. So we're going to use declare, and then we're going to use the name of the array. So in this case, the array has the name my list. So declare my list. We're going to use colons array, and here we're going to enter the lower bound and upper bound of this array. So this is the index positions where the lower bound and an upper bound is. So this is going to be a lower bound, and this is going to be our upper bound, right? So 0 is going to be our lower bound, and upper bound is going to be 7 in this case. And we're going to write the data type. So it's going to be an integer, since I want to store numbers into them. So what if I want to assign a specific value to any position in the index? How do I do that? So in order to do that, I'm going to use the command mylist, and I'm going to write the index position. So in this case, if I want to add to the position 7 a value of 16, so I'm going to do it this way. So when this command actually happens, so 16 is going to come and get stored over here. So this is how a 1D array works. Okay, so now we're gonna look at a 2D array. So I'm gonna import that array into the file. So here is our 2D array. So it consists of rows and columns. And as we are aware, rows and columns can be used to declare the upper bound and lower bound of this array, right? So in this case, if I want to declare the lower bound and upper bound for this, so I'm going to use the same declare statement as we use for variables or an 1D array. So I'm going to write declare, and I'm going to write my array, because this is what I want to name this. And it's going to be an array with a row and a column. So row is going to have their own upper bound and lower bound, and columns going to have their own. So for this case, I want to do 0 to 8 comma 0 to 2 of integer, since I want to store all integer values inside of this. So this is how I declare. And if I want to assign a value to this, I'm just going to write my array and wherever I want to do it. So 7 comma 0, if I want to assign this value 12, so it's going to assign it 12. That's basically how it works. And this is basically how you declare a 2D array. This can be useful in terms of making programs that display grids, such as a tic-tac-toe game or such as a snakes and ladder game. So this is very useful there in order to store which spaces have been occupied and all that stuff. So our next area of concern is using a linear search. So basically, if you have an array full of integers and you want to search something inside of it, so you're gonna have to write a program in order to like loop through it and check line by line. So linear search is the kind in which you check everything line by line in order to check if a certain item exists inside of an array or not. So we're going to be writing that algorithm here. So first of all, I'm going to declare an array. So declare my array, and it's going to be an array 0 to 8 of integer. So I'm gonna do of integer, and I'm gonna declare some variables I'm gonna use. So I'm gonna use the upper bound, and I'm going to use the lower bound. So these both are going to be integers as well. Apart from that, I'm going to use something known as an index variable. So we're going to go over how all of these variables do perform. That's going to be an integer as well. And declare item. So this is the item that the user is going to be inputting in order to search for it. So I'm going to use this as integer as well. And lastly, I'm going to have a flag in order to check if that item was found or not. So I'm going to use the variable found, and I'm going to assign it the data type boolean. So these are basically my declarations. I'm going to build upon my program for this. So I declared the array with a lower bound of 0 and an upper bound of 1. So I'm going to assign those values. So lower bound is going to be 0 and upper bound is going to be 8, right? Apart from that, I have to first ask the user what value he has to search. What value do you want to search? So we're gonna output that, then we're gonna take input and we're gonna write item here, since that is the variable that we decided upon. So first of all, we're gonna assign the flag we used above. It's a small case letter. So found, we're gonna be assigning that the value of false. I'm gonna assign the index value to be the lower bound. It's gonna iterate. So now what we're going to do is use a repeat loop. So a repeat structure is going to end as soon as a condition is satisfied. So I'm going to use a repeat loop, and I'm going to use an if condition, and if item equals to my list index. So my list index. So basically, oh my bad, I put it in wrong brackets. So it's going to be my list bracket index, right? So if item equals to my list index, so this means that the item is found. So what are we going to do? We're going to use the variable and assign that the value for true, right? So that's what we are going to do. Otherwise, we don't need to really change it back to false, because it's going to be false if this if condition isn't true, right? So we're going to use endif, and later on, next thing we're going to do is increment the index by 1. So index equals to index plus 1, and then lastly we're going to have our repeat condition. So until found equals to true. So there are two conditions: either found is going to be equal to true, or the index while looping is going to become greater than upper bound. So if index becomes greater than upper bound, that means you have already searched through all the index and you still haven't found the file or the item inputted by the user. So lastly, we're going to use if statement in order to see if found. So then output item found. If found equals to true, sorry. Else output item not found. And then basically we're going to use endif. So this is basically how you search for an item using linear search. There are multiple other methods, but for CAIE, this is the only method inside of our syllabus. So we're gonna move onwards to the last part concerning arrays, which is using bubble sort. So this basically is something concerning for a lot of students, because they don't really understand what's going on inside of it. So if you're given an array, any kind of an array, so whatever the spaces it may have, so basically this is our array. And if for example you have two values, 3 and 2, so this is array index 0, this is array index 1. So in order to organize this array into an ascending order, we need to use an algorithm. because if you can see 3 is obviously greater than 2, and if you want to assign it in ascending order, so you'll have to first have 2 and then you'll have to have 3. So you need to make a swap. You need to put the contents of array position 0 into array position 1 and array position 1 into array position 0. So the algorithm we're going to use is basically bubble sort. So we're going to be declaring some variables that are going to be useful. So first of all, I'm going to declare the array. So my list array, and my upper and lower bound for this is 0 to 8 of integer, because I want to sort integer values. I'm gonna do the same thing as I did last time. So I'm gonna declare upper and lower bound. So upper bound comma lower bound of integer, and I'm gonna declare the index, which is going to help us keep track of our looping. So declare index, and this is going to be an integer as well. And we're gonna declare 3 more variables in this. So we're gonna declare swap. So we're gonna use this to check if whether there has been a swap due to one number being greater than another or not. And we're gonna have declare temp. So this is gonna be a temporary variable, temporary spot where we store the greater value or the smaller value. Let's find out. So declare temp, and it's gonna be an integer as well. And lastly, we're gonna have declare top. So declare top, and that's gonna be integer as well. So when we start writing this algorithm, so we need to understand what's going on. So we're gonna have upper bound to be 8 and lower bound to be 0, and then we're gonna assign top the value of upper bound like we did last time. Then we're gonna have a repeat structure as well again, and we're gonna initialize our swap variable as false, and we're gonna try to prove this wrong. So whenever this is wrong, so we'll see what it does, what our algorithm does. So I'm gonna use a for loop now. So for index lower bound, okay, I used equals to, instead I'm gonna use an arrow. For index lower to top minus 1, and basically it's lower bound to top minus 1, my bad. So lower bound to top minus 1, and if my list index, so this is my list index, the value of the index is greater than my list index plus 1. So this is going to check the value of the current index, and then it's going to check the value of the next index and figure out which one's greater. So then temp will take my list index, and my list index will take my list index plus 1. So, and lastly, my list index plus 1 will take the value of temp, and that's basically it. After this has been done, the swap variable is going to become true, and then we're going to use endif, and we're going to do next index, and we're going to repeat this until not swap. So until the swap is false, or either we reach the variable top value to be 0. So this is how we use a bubble sort. So what's important here is we check whether the next value is greater than, if the original value is less than the next value, so here is it, or our current value is greater than the next value. If our current value is greater than the next value, then we're going to perform a swap, and we're going to do that till the end of the loop, and one by one it's going to check between each and every iteration, and then it's going to organize our array. So these are the parts concerning arrays. Thank you for watching.